All right, hi folks, this is Larry Mussolino. I wanted to record a quick video here on Module 3 and help you get started in some of the ZY Books activities for Module 3. I wanted to just do a few examples to help you with some of the concepts. So let me come here. This is section 3.2. It's called modular arithmetic. And what this is asking you to think about is really remainders from division. Let me give you an example here. Let's do this example right here. It says 12 mod 5. What this is asking you is if you take 12 divided by 5, what is the remainder? Well, I know I can multiply 5 times 2 and get 10. The remainder then would be 2. So this answer is 2. So imagine taking the number they give you, 12, divide it by this number 5, and ask yourself, what is the remainder? That's the answer to this modulus kind of question. And what they're saying here is if you take a number mod 5, the results that you can get are either 0, 1, 2, 3, or 4. Let me give you some examples here. What about 15 mod 5? Well, the remainder, when you take 15 divided by 5, the remainder is 0. How about 16 mod 5? Well, again, 3 times 5 is 15. The remainder would be 1. 17 mod 5. That's 2. 18 mod 5. That's 3. 19 mod 5. 19 mod 5. Well, I'll take 5 times 3. That's 15. Subtracted from 19, the remainder is 4. What if I go to 20 mod 5? Well, 20 mod 5 now, because 5 evenly divides into 20, there's no remainder, so this is 0. So you can see it's going to cycle back again and go through these results, 0, 1, 2, 3, 4. So that's what they mean when they say these are all the possible results for any operation, anything mod 5. The answers you get from this can only be 0, 1, 2, 3, 4. Let's do a couple of very quick examples here. Let me scroll down a little bit. And so some of this is terminology. And so here it says, what is the value of 5 times 7 in Z9? Really, this is asking you take 5 times 7 and work it out mod 9. That's really what they mean here. For the second one, they're saying 6 plus 8 mod 4. That's what they mean when they say Z sub 4. And the last one down here is 4 times 9 mod 6. Well, let's work it out. This first one here is 35 mod 9. Well, I know 9 goes into 35 4 times. No, I can't do 4 times because 4 times 9 is 36, but I could do 3 times. And that would be 27. 35 subtract 27 is 8. So this answer is going to be 8. 6 plus 8 here is 14. 14 mod 4. I know 4 times 3 is 12. That leaves a remainder of 2, so this answer is 2. 4 times 9 is 36. 36 mod 6. Well, 6 evenly divides into 36, so that means there'd be no remainder, so this answer is a 0. All right, so those are just a few quick examples here on doing modulus. Let me go to another topic here. Let me go to, how about this? It's called generalized product rule. So what this is asking you is, what if you had these, I'm going to jump to an example here. What if you had different ways to complete a task? Let's say you're going to get dressed in the morning. That's the task. Well, to get dressed, you would have to pick a pair of pants, let's say, pick a shirt, and pick shoes. So let's say you go to your closet and you see, oh, I have 4 pairs of pants that I can pick from. I have 3 shirts I can pick from, and I have 2 pairs of shoes I can pick from. Question is, how many different outfits can you create? Of course, an outfit would consist of certain pants, certain shirt, and certain shoes. Well, this rule says multiply these numbers together. And that's how you get the answer. So this would just be 4 times 3 times 2, 24 outfits. And this is a big time saver because I would not want to list out all the possibilities. Let's say I have blue pants, I have a white shirt, and I have black shoes. So that would be one outfit I could wear. I would have to list out all 24 of these combinations to get the answer if I was going to do it in, kind of an enumeration method, which of course is not the way to go because we can just multiply 4 times 3 times 2 together to get that result. All right. Let me do a couple of examples here, maybe. Let me scroll down. All right, let me scroll down here to this participation activity. Let's take a look at this. So it says here, imagine you have a club with 10 students, and you want to select a president, vice president, secretary, and treasurer. No student can hold more than one position. How many ways are there to select the class officers? Well, I like to create a little diagram to help me on this. So let's say here, I want to write down the number of ways to select the president. Then here, I want to select the number of ways I can select the vice president. Here is the secretary, and here is the treasurer. All right, well, I know I have 10 students to pick from. So really for president, I could pick any one of those 10 students. Now let me come to vice president. Well, I've already put, so this is really 10 ways to select. I've already selected one person to be president. Remember, no student can hold more than one position, so that person is out of the pool for vice presidents. I can't pick them again. So that means the pool only has 9 people now to select from. So there's only going to be 9 ways for vice president. How about secretary? I've already picked one person for president, one person for vice president. That means there's only 8 left for secretary, and of course 7 for treasurer. To find the total number of ways, you multiply these together, and the answer then is 50/40. Okay, so this is kind of the continuation of that product rule. We are taking the number of ways to select a president times the number of ways to select vice president and so on. This is just like how many ways can you select a pair of pants times how many ways can you select a shirt and so on. All right, let's go to the next one. The next one says, suppose there's 5 girls and 5 boys, but you want the president to be a girl. So again, I think this little diagram is a good way to go because it kind of helps you visualize. So here's president, vice president, secretary, treasurer. So president, vice president, secretary, treasurer. All right, well, what they're telling me is I want the president to be a girl, must be a girl. And I know there's 5 girls to pick from. So that means I have 5 choices to pick for the president, right? It's got to be a girl, and there's 5 girls to pick from. So there's 5 ways to fill in that first box. Let me come to the vice president. Now I know there's 10 people altogether, 10 total. For the vice president, there's no restriction. It could be a girl or a boy. But I've already picked one person for president. That means there's only 9 left for vice president. And of course, there's going to be 8 for secretary and 7 left over for treasurer. Multiply these numbers together, get the total number of ways. So there's 2,520 ways to select president, vice president, secretary, treasurer according to these constraints. All right, let's do one more example down here. Now, still there's 5 girls, 5 boys, but now the president is a girl and the vice president is a boy. All right, so let's fill this in. Here's the president, vice president, secretary, treasurer. I know there's 10 altogether, but the first box has to be a girl. And there's 5 girls to pick from. So that means I have 5 choices here. The second box for the vice president must be a boy. That was given to us in the problem. Well, there's 5 boys to pick from. How about secretary? Well, I've already picked a boy and a girl out of the total pool. Remember, the total here is 10. I've already selected 2 out of that pool for president and vice president. That leaves 8 left over. And treasurer, there's going to be 7 left to pick from. So if you multiply these numbers together, you get the result 1,400. Okay, so I think a little diagram like this is useful because it helps you to kind of organize your thinking as to how many ways can you fill each position. All right, let me go back and let's come here, permutations. So this is going to be important, permutations, because you're going to use this as for part of the Module 3 project. So let's talk about it. Here's the idea. We'd like to know how many ways are there to select a subset of items. We're going to call that R, out of a total of N items. And the important part of this is the order of the selection matters. So that's what permutation is all about. Selection, the order of the selection is important. Let me give you an example of that. Let's say I want to pick 3 people to serve as president, vice president, secretary. Well, of course, here the order matters, right? Because the president is like a different role than the vice president. So, if I pick John for president and Mary for vice president, that's a different order if I picked versus picking Mary for president and John for vice president. So the order is important here because these categories are unequal, right? President, vice president, secretary, those are like separate roles. What if I want 3 people to serve on a committee? Well, a committee order does not matter, right? On a committee, all 3 people are equal. That's one way to think about it. Well, if the order does not matter, this is going to be something called combinations, which we'll talk about in a minute. But if the order does matter, that's permutation, which is what we're talking about now. All right, so what we'd like to know is how many ways are there to select 3 people out of, let's say, 10 total? Let me use a different example. Let me just use 2. Maybe that'll be a little easier. So let's say, how many ways can I select a president and vice president out of 5 people total? Gonna have to ask myself, does order matter? Yeah, when I pick a president and vice president, that order matters because those 2 roles are not equal. Well, what you do is you say, how many people do you want to select at a time? Here it's 2, so that's R. R is 2. How many people total do you have? 5, so N is 5. So you come to this formula for permutations. Here it is, and we're just going to plug in some numbers. Now, first we have to know, what does this exclamation point mean? Well, an exclamation point is a math operation called factorial. And what it means, let's say you have 4 factorial. It says start with that number 4 and multiply it by all the whole numbers below until you get down to 1. So 4 factorial is just a shorthand to write 4 times 3 times 2 times 1. And that works out to be 24. 5 factorial is 5 times 4 times 3 times 2 times 1. If you multiply all this out, this is 120. And most calculators have a factorial button on them to make this, this calculation quicker. All right, so let's go ahead and do our example here. Let me erase some of this. So I'm going to work out P of 5 comma 2. That's our example here. So let's work out P of 5 comma 2. Remember, this first number is the N number. The second number is the R number. All right, let me plug into the formula. It says N factorial over N subtract R factorial. Let me plug in. Rn is 5, so it's going to be 5 factorial. On the bottom, we have 5 subtract 2 factorial. 5 factorial, well, let me write it as 5 factorial over 3 factorial, right? Because 5 subtract 2 is 3. Let me multiply all this out. All right, so we got 5 times 4 times 3 times 2 times 1 on top. That's the 5 factorial. On the bottom, we have 3 factorial, 3 times 2 times 1. Now, a little shortcut for these problems, as you do enough of these problems, you're going to notice that there could be some cancellation going on because I have a 3 on top and a 3 on the bottom, so I'll cancel those out. Same with 2 and same with 1. So I'm going to cancel all these out, and I'm left with just 5 times 4, which is 20. So that tells me there's 20 ways to select a president and vice president from 5 people total. And this is much quicker than trying to, list out all the possibilities. If you had 5 names listed out and you started forming different groups of 2, you would see there would end up being 20 different arrangements, ordered arrangements that you could create. Okay. Also, by the way, Excel does this for you. This permutation calculation. I posted a course announcement with details on Excel if you want to check that out. All right, let me go to the other part of this, which is combinations. So let me go to that. And sometimes they call that counting subsets. And so sometimes they call it counting subsets, R subsets, or R combinations. And so what we want to be able to do is figure this out using a formula. And remember, let me come down here. Let's do, where's the formula? Here we go. So we're going to write this as C n comma R. Let's do an example. How many ways are there to select a committee of 2 people? I'll say a committee of 2 members out of 5 people total. So the key part of this question is noticing when they talk about a committee, each person is equal, right? There's no ordering involved on a committee. So, if I wrote John, Mary as the committee members, well, that's really the same as Mary, John. This is different than president and vice president. Because if I told you the president and vice president are John and Mary, that would be different than if I told you the president and vice president were Mary and John, respectively. So this is going to be combinations. So the way I would write this is, let me just erase this over here. The way I would write this is C5 comma 2. Whoops. C5 comma 2. Now there's a special notation where you put the N and the R kind of vertically inside parentheses. So I could also write this as 5 over 2 like that. Same thing. Okay. Sometimes they also say 5 choose 2. Same thing. It means you're starting out with 5 and you want to choose 2 at a time. How many ways can you do it? Well, let's plug into the formula. The formula says n factorial over r factorial n minus r factorial. What you might notice here is this looks very similar to the permutation formula. There's an extra r factorial, though, down here on the bottom for the combination formula. So let's plug in. We know n is 5, and we know r is 2 in this example. So this is going to be 5 factorial over 2 factorial, 5 minus 2 factorial. So this is going to be 5 factorial over 2 factorial. In the parentheses here, 5 subtract 2 is 3. That's a 3 factorial. Let me write it all out. 5 factorial is 5 times 4 times 3 times 2 times 1. On the bottom, 2 factorial is 2 times 1. And 3 factorial is 3 times 2 times 1. I could multiply this all out top and bottom on my calculator, or I could do my little canceling trick because I'm noticing there's a 3 on top and bottom. Cancel those. There's a 2. There's a 1. I could do one more canceling here because I'm noticing I have a 4 on top and a 2 on the bottom. It's 4 divided by 2, so I can cancel out this 4 with the 2, and that would leave a 2. So it looks like I'm just left with 5 times 2, which is 10. So there's 10 ways to select 2 committee members at a time. Now, you might remember P 5, 2 was 20. We did that example a few minutes ago. We just found out that C 5, 2 is 10. It makes sense that the number of permutations should be greater than the number of combinations. Here's why. If I have Mary and John on the committee, the order doesn't matter. So I just count this once for combinations. But if I was talking about president and vice president, I would have to write it as Mary, John. That's one way to fill it, right? Because this would be the president versus vice president. But I could take that same combination and reverse it and make John the president and Mary the vice president. So if you notice, let me move this out of the way. For permutations, we had 2 different arrangements because we switched the names back and forth. So you can see in this example, we ended up with double the permutations compared to the number of combinations because each combination is counted once for the 2 names, but that same 2 names would count twice for the permutations. All right, hope this is helpful as you're working in Module 3. Let me know if you have any questions.